So we're going to continue with proofs from last time, but your given or your problem is either going to be about segments or about angles, okay? So when we first look at that, that's the first thing you want to think of. All right, is this a segments question or an angles question? And then I'll show you kind of what this should look like. So we always write our given first, okay? That comes first. Then let's say that they say AB or AC, your line segment B is in between them. So I still draw my picture. So B is between A and C. If it's between there, do I know, are they congruent or is it just in the middle, in between? Does that tell us anything about those two segments necessarily? So these aren't necessarily congruent, okay? But I can say, so once they give me that, I can say AB plus, what's my other part? BC will equal the whole, which is what? AC. Okay? So that will be kind of our starting off point once I have that given. Like, oh, okay, well then I know this part plus this part equals the whole. If you get to a test and forget, I would like you to put this, especially today, segment addition postulate, okay? Put that, but if you forget on a test, I would accept part plus part equals whole. On your homework, you shouldn't be doing that because you can use your notes. Just a last resort, okay? So that would tell me that then I could plug in like whatever they gave us. Okay, definition of midpoint or bisect could be your other reason. It is going to say in the given if you're going to use this. Like it will say maybe A is the midpoint of AB. So let's do that. So AB, M is the midpoint. Okay, if I have that, I know AM is what? Congruent to what other segment? MB, and I can mark that like that. Okay, that's what I know then. And that could be my first statement under the given. Okay, if we're talking about angles, do I need a pause? Okay. So angles, really similar. Angle addition postulate. So we don't know anything about if the angles are congruent on this one. So they're going to say something like, on angle ABC, D is on the interior. So interior means in between those, inside, right? So maybe I put D there. Okay, now I want to name these two parts, okay? What is this angle? This top angle is what? ABD. So I'm going to say angle ABD plus, because I'm doing angle addition, what is the bottom angle here? How would I name it? DBC equals, what is the whole? Yes, sorry, ran out of room. Equals ABC. Again, that is part plus part equals the whole, but try to use angle addition postulate if you can, okay? I just think, okay, I'm taking two angles and I'm adding them, so it's got to be that one. Okay, definition of bisect is similar. But what does the word bisect tell us? Both angles are the same. So if I say BD bisects angle ABC, that means our big one is cut in half. That makes the top congruent to the bottom. Remember these two swoops in the angles here? They mean telling us congruent, correct. So then for that, my starting off statement could be angle ABD is congruent to what other angle? DBC. Okay, so example 1. Solve each problem, then write a 2-column proof. So when you do a proof, remember the left side is your statement, right side is your reasons. And reasons could be postulates, like we just talked about, definitions, properties. Could they simplify, combine like terms, okay? Or what's our first reason always? Given. So let's start with that real quick. I'm probably not going to be able to write all of that on there, so let's, if it's a test or something, write all of it. But for today, you can do, so point B is between A and C. I want to put dot, 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 which just means and so forth, okay? Reason is given. Okay, and you just want to kind of pretend for a minute that I don't have this proof for a minute. I just want to, if this was just a problem that I was given, what would you start off with doing? So point B is between A and C. What?
Putting it at an angle.
Okay, not an angle though. How do we know this is a segment? What gives us a clue that it's a segment?
Oh, the line.
Lines, and they tell us only 2 points on a segment, all right? Angle will be 3. So point B is between A and C. Is it exactly in the middle? No, just somewhere. So I like to make it where it's obviously not in the middle. That way I know, like, okay, those aren't congruent. It's just in the middle. It's somewhere in there. Okay, now we can label. So AB is 3x minus 2. BC.
2x plus 14.
And do we have the whole?
Correction.
Yes. 3x plus 42. Okay, so I want you to get in the habit today of flipping back to that first page and picking out if it is segments or angles, and then which of those two reasons will go with. So if we pick segment addition postulate, we want to use that to help us write. Don't plug in yet though, all right? So our first segment is AB. So AB addition, right? So plus. What is the other part of that segment? The other small part would be what? BC. Okay. What's the whole? AC. And then we said that was what reason? Segment. Oh, what just happened? Segment addition postulate. You can abbreviate there if you want. Okay, now you guys know, all right, well, I can plug in for those values since they gave them to me. Okay, so Caitlin, what are you going to put in for AB? AB, the first one.
Wait, like how do you solve it?
Just like this AB, what do I replace it with from our information?
3x minus 2.
Yes, so I replace it. Okay, BC is 2x plus 14. And then our whole, I replace with 3x plus, good.
Would it be the same reason?
No, it's not the same reason. Okay, when we plug in, we're going to see this one a lot. So your properties from last time, what was that, Flavia? Is that you or Preston? Substitution. We're going to plug in a lot today, okay? So get that one memorized. Substitution. It's not a property of equality because I'm not plugging the same thing in on both sides, okay? Or I'm not doing the same operation to both sides. It's just substitution. Okay, now we can start solving, and this is just like our equations proofs from last time, okay? So what would we do after this?
Combine like that.
Combine like terms. So I'm going to go ahead and write that. CLT. How many x's will I have now once I combine these? 5x. My constants, negative 2 and 14, will now give us 12. Bring down my right side. Okay. And start solving from there. So, a couple ways you could go, right? And it could still be all right. We could do it different ways. Josh, what would you do next? Which one? The 12? Okay, so my minus 12 from 42. That would give me 30. I'm going to do the x's at the same time. So can I move the 3x to the 5? How would I do that? Add or subtract? Subtract. So that gives me 2x. So since I subtracted for both of them, what is my reason now?
Add, subtract.
What? Subtraction property of equality. Because I did do it to both sides. Okay, the x is almost done. What do I do to finish off that x? Divide. So x equals what? 15. And that was my reason would be? Yeah, division property of equality.
What does TO stand for?
Oh, we're not done because my final answer needs to match this prove. But I'm pretty close. How can I get BC if I now have x?
Plug it in.
Okay, now be specific. BC equals, what's it going to look like plugged in? 2
Times
times
15
15.
plus 20.
Okay. So when I plug in every time, that property is
Multiplication.
no substitution. Not multiplication because I'm not multiplying by the same thing on each side. Remember, that would be of equality. All right, and I just simplify that. So 2 times 15 is what?
30.
30 plus 14. Right. So it should be matching up there. If not, something went wrong. Final reason would be what? Essentially, you're just going to type this into your calculator, right? Or just do it in your head. But anytime you're just sort of combining everything, we can just say simplify. Probably wouldn't be too picky on that, but just heads up. Our second one here. Are we talking about angles or segments here? Angles. So let's draw the picture. Take like a minute here, draw the picture, and label the parts. Okay, so hopefully you guys have drawn that, so let's check and see. So ABC should have been the big like outside angle. Okay, we had a important word here, which was bisects. So that means the x needs to be in the middle. If it's cutting through the middle, it's going to be out here in the middle. Okay. It says ABX, so that is our top angle, is 3x plus 23. CBX, the bottom one, is 2x.
Plus 30.
Whoops. Okay. We cannot use the 136 yet, though. Okay, so don't think you can use that in your equation. Not yet. We're trying to prove that. So let's write, what do we write first? All right, so let's see how we can write this from here. So what do we need to write first?
Line BX.
Ray, but yes.
Yeah, my bad. Bisects
Uh-huh.
angle ABC.
Good job. Okay, now I'm going to put, that's not all it says, right? So I'm going to put ... for now.
Yep.
Test, remember, write the whole thing. Okay, don't be lazy then, just right now. All right, now flip back to that first page of your notes. We're talking about angles of today's notes. Sorry, today's notes. So we're talking about angles. So we have two options for our first line there. It could be angle addition or definition of bisect.
Definition of
Definition of bisect. So what should that first, I'm going to say that's my reason. So looking at that, what should my first statement look like?
ABX equals
Angle ABX. What's the equals word for geometry? Congruent to what?
XBC.
XBC. Okay? We know that they're congruent because that's what bisect means. It means it cuts that in half and it sets those two equal. It's two equal halves. Okay, they gave us a value or at least an expression for those angles. Okay, so what should I do now with them? If I already have them.
Plug in.
Yes, plug in. So 3x plus 23. Can I replace congruent with equals?
Yeah.
Is that kind of the same? Yes. So I'm going to make that equals. XBC is
2x plus 30.
good. And then what property tells us that we can plug in? Substitution. Okay, I would solve next by, Caitlin, what would you do?
You would move the 2x over and
By adding, subtracting, multiplying, dividing?
Subtract 2 from the 3x.
Right, so now I have x, and I want to move my 23 over by doing what, Preston? How would I move 23 to the right?
Subtract it.
Okay, so 38 minus 23 gives us 15. What's my reason?
TLT.
Ooh, nope. Subtraction, and then how do we say it? What's that stand for, though? Property of
Equation.
equality. Close. Okay, so we're not quite done here. We got a good start. We got x, okay? But we need to know the whole thing, right? Yeah. So there's a couple routes you could take here, okay? I'm going to plug into 3x plus 23. So I'm going to say angle ABC equals 3 times 15 plus 23. Okay, Riley, if we plug in, what property tells us we can do that?
Substitution.
Good, substitution again. Told you you'll see it a lot. Okay, I want to simplify that, so you want to type this part in your calculator or do it in your head, either way, but better be right. So 3 times 15 plus 23. So basically 45 plus 23, yes. Okay, if I just plug in my calculator or plug in my head, what's my reason? Starts with an S. They seem to all start with an S.
Simplify.
Yes, simplify. Okay. Now, Caitlin said here that she wants to take it and then do what with it?
Plug back into the other one.
We could plug into the other one, but
You could add 68 plus 68.
Oh, yeah.
because did we already say that they're congruent?
Yeah.
Yes, so we said they're congruent, so we can kind of just say, all right, well, I know that one plus that one will equal the whole. So let's do 68, and again, there's a couple ways you could go here. Oh, this was supposed to be an X, sorry. Make this an X, my bad. Now we're doing A, B, C. So add those in, and why are they equal? What told us that they were equal, that we can add those two to get the total? Bisect. So you can just use that reason again, definition of bisect. Okay, so now angle ABC equals what? 136. Now that does look pretty close to my proof, but let's go ahead and make it look exact. M just means measure of the angle, and I'm going to throw that degree on the end. And I just added 68 and 68, right? So I did what? Simplified. So a lot of simplify, a lot of substitution. All right, 3 is a little bit different, so I want you guys to take don't start your proof yet. Well, actually do this. Draw the picture and write the first line of your proof, and then we'll check back. All right, so was this a segment or an angle?
It is a segment.
Yes. So I draw my line, X, Y. M is the midpoint. Okay, so that's going to be important. It says XY is 4x plus 12, so that is the whole thing. XM is 3x minus 6. So a few of you are like, oh no, I do not have the other side. But we'll get back to that. It's fixable. So my first line should say M is I'm going to say just MP of XY. And that is my given. Okay, so looking back here, our keyword is midpoint. On your first page of today's notes, you can either use segment addition or definition of midpoint bisect. What you think we're going to use on this one?
Midpoint.
Right, because it has the word in there. So I'm going to say definition of midpoint. So look at that page if you need. If it is definition of midpoint, what is this first statement here going to look like? It's going to tell us what about those two segments. Okay, now use the letters. So XM congruent to, what'd you say?
MY.
MY. Because that's what midpoint means. It means those two parts are equal to each other, congruent to each other. All right, now here's where you guys maybe got tricked. If xm is congruent to my, okay, I put my little congruent markings right here. What can I do with that 3x minus 6?
Times it by 2.
Yeah, it's congruent.
You can times it by 2. I think most of you guys did copy over on the last one. That's fine too. You are essentially going to add those two together, which is the same as times by 2, right? So either option would work there, and that's where I told you sometimes people take different methods, and that's okay. So I'm going to now say, gotta kind of go from here. So if that xm equals 3x minus 6, I'm going to say, all right, well, that is 2. And let's write that out. This is kind of a long one. I'm going to say the same reason, definition of midpoint, okay? But this equation doesn't necessarily help me write my final one, okay? So Charles said we can times them by 2. I could also add them and set them equal, right? Either way will work. Let's do the times by 2 method because we haven't done that yet. So I'm going to say 2 times 3x minus 6 equals, what is the total?
4x.
Uh-huh. I'm going to put these little lines here because that means the same thing. Still definition of midpoint, okay?
6x, right?
You also say.
No, it's 4x. It's the bottom thing.
Right here.
Yeah.
The total. We're going to get to the 6x though because we can now do what to solve this?
Distribute.
Distribute. So now we have 6x minus 12 equals 4x plus 12. And if we distributed, our reason is?
Distribute.
Yes.
Well, what's the one above that?
So this, the little lines mean the same thing as the line above it. I was being lazy. Okay, what would we do next? How would we solve?
4x.
Subtract 4x, giving us 2x, adding 12 to give us 24. So my reason, I would want to put both. Add and subtract property of equalities. Thomas, what is x going to equal now if I got 2x equals 24? 12. And what was your reason for doing that? What property? Right, so division, POE. Okay, we're almost done. So who can tell me what you want to do to get XM now? What do we do?
Plug it in.
Plug it in, and I want to make sure I plug into XM, right? So XM equals 3, parentheses 12, minus 6. If I plug in, that is,
32.
well, what property do I plug in with, though?
Substitution.
Yeah. Okay, and I'm going to simplify. 3 times 12 is 36 minus 6. Does that equal 30? Yeah. So XM does equal 30. I just simplified to get that. Okay, so let's go ahead and check in what we got here. So angle XYZ was the big outside angle. And it says T is on the interior. So just somewhere inside, I'm going to connect out to T. Okay. Then label XYT, that would be the top angle here, is 3x plus 3. TYZ, I'm going to skip over this for a sec. TYZ is our bottom, and that's 6x minus 12. All right, and the whole thing is XYZ. So I like to label that like this. Okay, so first line should say what? Alexa, start us off on the first line. What would it say? So point T is on the interior ... That's all I could fit. Given. Okay, now I think you all realize that we were talking about angles because that's what you drew on your pictures. So from your first part of today's notes, that means you could now use angle addition postulate or definition of bisect. All right, they did not use the word bisect in the given, so it's not that, okay? So angle addition, if you want to do your angle symbol like this, that's fine. Okay, so look back at that, because before I plug in those numbers, I want to use the letters set up, okay? So angle, the first angle, the small part, would be XYT, addition, right? So plus angle, what's the other one? TYZ is equal to, what is the whole?
XYZ.
Oh, yes. Okay, now we can plug in. So if we plugged in, actually what property is plug in? So substitution, because if I'm not here and I have a substitute, it's going to replace me or fill in. Okay, Ryan, what am I ready to do now? Not yet. Let's do our like terms. So I'm going to do combine like terms. So I can do, what can I put with the 3x? Okay, so now I have 9x. And 3 and negative 12 would give us? Careful.
9.
Negative 9. Okay. And then nothing to simplify yet on the right. Okay, couple ways we could go from here, okay? Let's just pick. Paige, what do you want to do first? Do you want to move the x's or the constants?
The constants.
Okay, which one?
Add the 9 to 18.
Okay, so if I add 9 to negative 18, I would get negative 9. Since we moved the negative 9, I have to move the 10. So I would subtract 10 from 9x, giving me what? Negative 1x. Okay, an equation is not done if the number, or the coefficient, so the number with the variable is negative. So how do I get rid of that negative? Divide by negative 1, so x equals 9. Okay, hold on, I forgot to write my. So here I subtracted / add property of equality, and then the very last one we just divided, right? Okay, are we done?
Yeah.
We are done because it says prove. You may have used the other line if you added 18 and subtracted 9, but then you would have ended up actually with 9 equals x, and you would have had to flip it to be x equals 9 by using the symmetric property, technically. Okay, so if you did it that way, it may have came out like that. Okay?